Today we will learn a few methods in solving limits with trigonometric identities. When solving limits with trigonometry, we will use the trigonometric formulas. In the description below, I have a PDF file for you with all the trigonometric formulas that you will need when solving the limits. Now let's take this example. Here we are asked to find the limit of x squared divided by 1 minus cos x as x tends to 0. In limits, most of the time we convert the cosine terms into sine terms. This is because the only theorem we know has sine in it and not cosine. So there is a higher chance of us using this theorem, as you will see when solving this question. So here cos x can be written as 1 minus 2 sine squared x over 2. This is from the half angle formula we learned in trigonometry, that is cos 2x equals 1 minus 2 sine squared x. The other reason why we use this formula is because now we can cancel off 1. So this gives us positive 2 sine squared x over 2. So what we do is then we take this 2 out and we apply the limit to the denominator, and also we bring this x squared to the denominator. So that will be limit of sine squared x over 2 divided by x squared as x tends to 0. So then what we do is we separate this sine squared x over 2 divided by x squared into two limits, that is sine x over 2 divided by x into sine x over 2 divided by x, and we apply the limits separately. So now we want to get this formula. Basically we want to get this in this form. So for that we need to get x over 2 here. So what we do here is we divide this denominator by 2 and also the numerator we divide it by 2. So that way it gets balanced off. We do the same thing for this part as well. We divide this denominator by 2, and here this numerator part also we divide by 2. That way it gets balanced. So now here you can see it is in this form, that is sine x over x. Instead of sine x over x, we have sine x over 2 divided by x over 2. So it is in this form. But here it is x tends to 0. If we want to get it to this form, we need to be as x over 2 tends to 0. So what we do here is we simply change it, because as x tends to 0, x over 2 will also tend to 0. So we can write this as half into 1 over limit of sine x over 2 divided by x over 2 as x over 2 tends to 0. Multiplied by 1 over 1 over 2 multiplied by 1 over limit of sine x over 2 divided by x over 2 as x over 2 tends to 0, multiplied by 1 over 1 over 2. So now we have these two in the expected theorem form here. So we can substitute this for 1. So that will be 1 over 2 into 1 over, this will be equal to 1. And this 1 over 2, this 2 will go up, giving us 2 into 1 divided by this part will also become 1. And here this 2 also will go to the numerator, giving us 2. So finally we can get our answer as 2. So here we saw how to convert our cosine values to sine values, and also we utilized our theorem to get our final answer. So now let's look into another question. So here we are asked to find the limit of 1 minus sine 2x divided by x minus pi over 4 as x tends to pi over 4. So what we do here is we bring this pi over 4 to this left hand side. So that will be x minus pi over 4 tends to 0. So now what we do is we let this x minus pi over 4 equals y. So basically we are causing a substitution, and therefore x will be equal to pi over 4 plus y. So now we substitute this into our question. So that will be limit of 1 minus sine 2 into, instead of x we write pi over 4 plus y divided by, instead of x we write pi over 4 plus y minus pi over 4, and this will change into y tends to 0. Now we can simplify it. Here pi over 4 will cancel off this pi over 4, and when we multiply this 2 into this bracket, we get limit of 1 minus sine pi over 2 plus 2y divided by y. Now from trigonometry we know we can write sine 90 plus 2y will be equal to cos 2y. So this we learn in our trigonometry. So we can change this into 1 minus cos 2y divided by y. So like I mentioned earlier, when we get a cos value, most of the time we convert it into a sine value. So we change this cos 2y into 1 minus 2 sine squared y. So here 1 and 1 will cancel off, giving us positive 2 sine squared y divided by y. So now we then separate it. We take this 2 out and we apply the limits separately. Limit of sine y over y we take separate, and the remaining sine y we apply a separate limit. So this gives us 2 into 1 into, here we use direct substitution. So sine 0 will be equal to 0. So our final answer will be 0. So those are some of the methods that we can use to solve trigonometric related questions. In our next video, we will learn more methods to solve trigonometric related questions in limits. Until we meet again, take care.